Hey everyone, and welcome back to mathMinutes. In this video, we're going to explore upper bounds and lower bounds. In mathematics, when we round a number, there is usually a range of numbers that could round to that very same number. The upper and lower bounds tell us the maximum and minimum values that our rounded number could actually be. So, in other words, the upper bound is the highest possible value that a number could be and still be rounded down to our rounded number. Note that the actual value is strictly smaller than the upper bound. The lower bound is the lowest possible value that a number could be and still be rounded up to our rounded number. Note here that the actual value is greater than or equal to the lower bound. Let's look at an example to better understand this. Suppose we're given a pencil and told that it has a length of 10 centimeters rounded to the nearest centimeter. Since the length of our pencil has been rounded to the nearest centimeter, we know that the pencil can be slightly shorter or slightly longer than this number. For instance, if the actual length of the pencil was 9.8 centimeters, it would still be rounded up to 10 centimeters. So let's find the shortest and longest that our pencil can be. The lower bound is the smallest length the pencil could be and still be rounded to 10 centimeters. Our rounding unit is centimeters, so we see that if our pencil length was 9.5 centimeters or more, it would still round up to 10 centimeters. If it was anything less, such as 9.4 centimeters for instance, then the length of the pencil would be rounded down to 9 centimeters. Similarly, the upper bound is the largest length that the pencil could be and still be rounded down to 10 centimeters. If the length of the pencil was less than 10.5 centimeters, it would be rounded down to 10 centimeters. If it was 10.5 or anything more, we know that 10.5 rounds up to 11 centimeters to the nearest centimeter. So, we can see a range of values that the pencil could actually be, a lower bound of 9.5 centimeters and an upper bound of 10.5 centimeters. We can show this interval of values using inequalities. Remember, the actual length of the pencil must be greater than or equal to the lower bound, so we use the greater than or equal sign. The actual value must also be smaller than the upper bound, since if it was equal to 10.5 centimeters, then it would round up to 11 centimeters. So here, we use the less than sign. This means we can write our interval as... Let's look more precisely at how we can find the upper and lower bounds. First, we must identify the rounding unit, or the place value to which our number has been rounded. Now, for any rounding unit, we can see that the actual value that a number could be is up to half a unit larger or smaller. So, we divide the rounding unit by 2. The final step is to subtract this number from the number given to find the lower bound, and to add this amount to the number given to find the upper bound. Let's look at another example. Suppose we have a bag of flour that has a weight of 950 grams, rounded to the nearest 10 grams. Our rounding unit is 10 grams, so let's divide this by 2. Now, to find the lower bound, we subtract this value from 950, which equals 945 grams. Similarly, to find the upper bound, we add 5 to 950 to get 955 grams. We can write this in an interval. Remember, our actual value is greater than or equal to the lower bound, and is strictly less than the upper bound. Now let's move on to a more mathematical example and calculate with rounded numbers. Suppose we have a rectangle with sides 4.1 centimeters and 6.7 centimeters, rounded to the nearest millimeter. Let's find the minimum and maximum possible perimeter. To work this out, let's first calculate the upper and lower bounds of the sides of the rectangle. First, let's identify our rounding unit, which is 1 millimeter, or in other words, we can write this as 0.1 centimeters. We divide this value by 2. So we can see that the upper bound for the side 4.1 centimeters is 4.15 centimeters, and the lower bound for 4.1 centimeters is 4.05 centimeters. Similarly, the upper bound for the side 6.7 centimeters is 6.75 centimeters, and the lower bound for 6.7 centimeters is 6.65 centimeters. Now, to find the minimum possible perimeter, we use the lowest possible values that the sides of the rectangle can be in our calculation for the perimeter. In other words, we use the lower bounds, 4.05 times 2 plus 6.65 times 2, which equals 21.4 centimeters. Similarly, to find the maximum possible perimeter, we use the highest possible value that the sides of the rectangle can be in our calculation for the perimeter. In other words, we use the upper bounds. 4.15 times 2 plus 6.75 times 2, which equals 21.8 centimeters. Now, let's find the minimum and maximum possible area. As for the perimeter, we use the upper and lower bounds to work this out. To find the minimum possible area, we use the lowest possible values that the sides of the rectangle can be in our calculation for the area. 4.05 times 6.65, which equals 26.9325. But hold on, remember, the question asks for us to give our answer rounded to 2 decimal places, so we round the answer to 26.93 centimeters squared. Now, to find the maximum possible area, we use the highest possible values that the sides of the rectangle can be in our calculation for the area. 4.15 times 6.75, which equals 28.0125. We round this to 28.01 centimeters squared. Great! Now you know how to find upper and lower bounds. You may wonder why they are important in the context of mathematics, but think of when we measure or estimate something. We're often rounding to a number. This means there are uncertainties between the actual number and the number that we've rounded. These uncertainties lead to ranges of possible values rather than just one exact value. That's where upper and lower bounds come into play. That's all for this video. If you have any questions or want to see more videos like this, let us know in the comments below. Thanks for watching, and don't forget to hit that like button and subscribe to our channel for more math content.